All right, everybody. Today we're going to be talking about completing the square. I'm here with Mrs. Nebeker, who has been singing to me for the last like 10 minutes. Did you want to keep singing, Mrs. Nebeker?
No, thank you.
Okay. Did you want to share that awesome song you've been singing? Oh, okay. Well, that's great.
It was just for you.
Just for me. All right. So, great. So, to complete the square, so remember we want a perfect square. If you remember factoring, you remember when you had like x plus 2 squared, which was the same as like those multiplying together, right? Like this, x plus 2 together. We want to be able to factor a part of this equation down to that form so that we can then solve for a variable. So what we do to do that is the first thing we're going to do is we're going to kind of group our x's together, kind of like that. Okay, kind of ignoring these other numbers for now. We're going to look at just these two. So if I were to rewrite this, x squared minus 14x, I want to figure out what third term I could put in here that would produce a perfect square. So something that would be a perfect square that could factor down into what I showed you up there, the x plus 2 squared, something like that. So to do that, what you do is with the middle term, so that 14x, you need to divide that coefficient by 2. So if we divide that coefficient by 2, that 14, we would get 7, right? So that would be what I would need to square to get my third term. 7 squared is 49. So that is something I'm doing to complete the square so I can factor that down. Now, we still have this minus 19 here, and we still have negative 10. Now that 49 can't come out of nowhere. I have to cancel out that 49 that I just did. So to cancel out that 49 that I just threw in here, just willy-nilly, I then subtract it right here. Because 49 minus 49 is 0. So it's just manipulating the equation a little bit, but I'm not changing the equation at all, right? These still would cancel out when I combine them. But this right here can then be broken down into a perfect square, one of our special cases, right? When you have double the middle and you have the perfect square on both sides, you can rewrite that as x minus 7 being multiplied by itself twice, right? And that would be the same thing as writing x minus 7 squared. Okay? Now I'm going to combine these two terms out here, negative 19 and negative 49. They would combine to become negative 58, right? Or 68, negative 68, sorry. Negative 68 equals negative 10. And then I need to get this all by itself. So I would add 68 to each side, add 68. Gives me x minus 7 squared is equal to positive 58. Now this is where we have to solve using the square root. So this is something squared. If I want to undo that square, I've got to square root both sides. Okay, so I square root that. Now the issue here is that when I square root something, it's a plus or minus, right? So I would have x minus 7 is equal to plus or minus square root of 58, which gives me two possibilities, right? X minus 7 is equal to positive square root of 58, and I can't simplify that down anymore, in case you're wondering. And x minus 7 equals to negative square root of 58. So this is where I have to split it into two possibilities, square root of 58, and x minus 7 is equal to the negative square root of 58. And then to solve those, I add 7 each side, and I can't combine those because this is a radical, right? So I'm just going to end up with two answers. I'm going to have x is equal to 7 plus the square root of 58, and x is equal to 7 minus the square root of 58. And that would be my two answers. That's as simple as I can get it in radical form, which is what we're going to try to leave it as. If I wanted decimals, I could obviously get it down, but it wouldn't be as accurate because it would be long repeating decimals there. Okay, let's do another one. So let's look at this one. So again, I start off by isolating my two variables. So p squared minus 12p. Then, this is where I need to divide by the middle term. So divide the negative 12 by 2, and I'm going to get 6, right? 6 squared is 36. So I can rewrite this as p squared minus 12p plus 36. That's the perfect square that I can then break down into the factored form over here. However, I still have this plus 27 here, but again, since I added in this 36, I've got to cancel it out, so I throw in a negative 36 or a minus 36 on that same side, because if I combine those, they go to 0. It's like I didn't do anything to the equation, even though I did. And then I still have that 7 on the other side. So again, this is a perfect square. It can break down into p minus 6 squared. And then 27 minus 36 would be negative 9. So minus 9 is equal to 7. So I add 9 to each side. Gives me 18. So I have p minus 6 squared is equal to 18. Now, this is where I do the square root to each side. That gets rid of my square over here, so I have p minus 6, but I don't know if this is a plus or minus 18 over here. So, wait, did I do something wrong? No, I didn't. Okay. Hold on. I did do something wrong. Derp. Okay. 9 plus 7 is not 18. It is 16. No judging over there. Which does have a square root, right? The square root of 16 is 4. So it is 4, but again, I don't know if that was a positive 4 or a negative 4. There's two possibilities. So this is where I have to solve for both possibilities. So I have p minus 6 is equal to positive 4. P minus 6 is equal to negative 4. I'm going to add 6 to each side. And I would get p is equal to 10. Or I would get p is equal to 2. And that would be my two possible answers. Okay, and that's how you do or solve a problem using completing the square. It's a few steps, but again, once you get the hang of it, they're not too tough.